All right, so here are two angles who aren't really triangles, but they are important for you to understand. So there's the angle, the triangle where the angle is 0 over here, and there's a triangle where the angle is pi over 2. Where's my cursor? Over here. All right. So I'm just trying to make sure you understand what's going on with these two triangles. So you know when our angle of the triangle was like pi over 6, it was really, really small. So the opposite, the height of that triangle was a pretty small number. It was just 1/2. So as the angle gets smaller and smaller and smaller, the length of the opposite is getting smaller and smaller and smaller. So a triangle with the angle of 0 just doesn't have an opposite. So the length of the opposite is 0, meaning that if the length of the opposite is 0, then that means the hypotenuse and the adjacent are just coming closer and closer and closer together until they're the same. So if we're talking about the unit circle, the hypotenuse is 1, so the adjacent is 1. And it's sort of a similar story, but sort of the opposite for the 90-degree angle for the pi over 2. We know when we have the pi over 3 angle, when the angle is pretty big. I'm actually not going to draw like that because I always draw really weirdly. But like that. No, it looks the same. Oop, like that. I don't know. Fuck. Pi over 3, right? We know when the angle is pi over 3, the adjacent value gets smaller as the angle is getting bigger and bigger. So if the angle is getting bigger and bigger and bigger, the adjacent is going to be really, really small. So as the angle gets bigger, the adjacent pretty much goes to 0. So this is the angle 90. It's just a complete vertical line because the hypotenuse is trying to meet the opposite value, right? So it's like a similar story with the 0 angle. So here, the adjacent is going to be 0, the opposite is going to be 1, and the hypotenuse is going to be 1. So it's just a way you can think about it. I'm just going to redraw it so that it's easier to do. Okay, so these are the two triangles that we're talking about. So for the 0 angle, we talked about how if the angle is 0, the opposite side has no height, right? Has no length, has no nothing. So the opposite, I'm going to make it black. The opposite is going to have a length of 0, but you know, a line. So the hypotenuse and the adjacent are going to be the same length. And if we're talking about the unit circle, that length is 1. So hypotenuse is 1, so the adjacent is 1. And now we're thinking about it on the 90 degree, right? So here, the adjacent, the top, has no length because it's so close, they're so close to each other, and the hypotenuse and the opposite are going to be the same length, right? Because it's a vertical line. So here, so the hypotenuse is always going to be 1, the adjacent is going to be 0, and the opposite is going to be 1 because it's a vertical line, right? This one is a horizontal line. So now I wanted to make sure that we understand what the sine, cosine, and tangent were of all these. So here, the sine of 0 is going to be the opposite over here, over the hypotenuse, which is going to be 0. The cosine of 0 is going to be the adjacent over here, over the hypotenuse, which is going to be 1. And the tangent of 0 is going to be the opposite over the adjacent, which is going to be 0, or also the sine divided by the cosine. And over on the 90 pi over 2 side, the sine of pi over 2 is going to be 1 over 1, which is just 1. The cosine of pi over 2 is going to be the opposite over the hypotenuse, which is going to be 0. And the tangent of pi over 2 is going to be the opposite over the adjacent, which is 1 over 0. But that's undefined. So the tangent of pi over 2 is always going to be undefined. So important to note. All right.